Okay, we are back with more information about the future of chatbots. This here looks like the American flag, but it's not, I think. It's some kind of candy. I live in a nice, colorful place here. The thing I want to show you is the distinction between two types of making a chatbot. After like years of spinning this inside of my head, I realized that there's a critical distinction. The chatbot is some program that understands language and responds with language, preferably a live language like English, not Latin or COBOL. So, how do you make a chatbot? There are two ways. One is to make a program, an explicit program in an existing programming language, enriched with suitable library functions. The other way is to use natural language. This was the first way. Here it's a work in progress. Here I use the other way. Here I make rules that I specify in English. Here is a replacement, for example. Input is what have we got, and it's rewritten to another input that is show values, and this is wired somewhere in a way that the bot understands. Actually, it's here, some other rule. So in the other rule, this rewritten command is translated into actual Java. This is a bit of Java. So if you make a bot with natural language, like here, you will embed in this little fragments of code, Java code. And if you make a bot in a language, like Java X here, or Java or something, then you will embed language, like here. Just the approach is different. One time you focus on the program, one time you focus on the language content. And it turns out both of these have very distinct advantages and disadvantages. If I make an actual program, this is an actual program, it tells you the time, and it's really eager to do so. When you start the program, it says, do you want to know the current time? And you say yes, and it says you the time. Then you can say, do it again, or can you do anything else? And it says no, because it knows that it has only one function, which is telling the time. You can also do things and something. And this forms a complete program. It's translated into Java. I show you the translation to Java. The website does it automatically. So this Java X thing turns into 7,000 lines of Java code. It drags in all the functions it needs. This is the same program, and here lots of helper functions. But this is the point is this is clearly defined. This program, these classes that are used, it's called attractor bot. It's a bot that manages different attractors. An attractor is something that accepts input. This attractor matches on a question, can you do anything else? This attractor matches on thanks and says, you're welcome. And there's a default attractor. You can put it in the end of the queue, so to speak, to catch any other input. I think maybe if it says, do you want to know the current time? It defaults to yes. No, it doesn't. Do you want to know the current time? If you say yes or something similar, there's another function that defines what yes means. You can say sure or I accept. And the low priority attractor is the default. No, it means no. Do you want to know the current time? And you say screw you, then it says okay, you do not want to know the current time. So this is a precisely defined program if you take these library functions into account. These natural language rules are maybe not so well defined. The point is that behind this simple rule, there is technical information. I call it comments here. For example, that the machine is flexible here. This is an example given. And if you, instead of pick me up, you say leave me alone at 11 a.m., it will probably say time of leave me alone or something. It will change the output when the input changes in quite a magical way. And you can change that here. You can say, oh, this word does have to be there, otherwise the rule makes no sense. and it's similar with other rules. So this seems like an easier way. You can just put examples here or some meta instructions. This is the meta instruction that says split the input into sentences. Whenever there's a full stop, it splits, or split at commas. Pre-processing things can also be expressed as a rule. And you can have multiple inputs here, like things that were said before. If user said, "Hi, would you like to continue scheduling your car rental?" I mean, the bot said this. And the user says yes, then the bot says okay. And it gives a command to itself. This is funny. The values command is a command to itself. Here it's rewritten, and then it shows the current values. And this is a bot that schedules things for you. It asks you about a time and a date, and return time, return date. And it says, "I have a car for you. Hopefully this and that date." So I'm still not sure which way to use this natural language approach or this programming approach. This is kind of better because this is precisely defined, and in this kind of bot you can easily see what happens when there's no if then else in here, but this attractor thing is similar. Only some attractors are active at any time, and many only for one line. Bot asks the question, and if you don't answer the question, it just forgets about the question and reacts to what you say. This is easy to debug. This is easy to ship to a customer. This can also be shipped, but you need to ship a bigger program with databases behind it often. Yeah, but the point is we are approaching the AI question from two sides, from making smarter programs from one side, and the other side is just making natural language rules, because these rules here are pretty much examples. These are examples of input, and they're generalized. For example, here is 9 a.m. a clock time, blah, blah. Why is that? What? 9 a.m. I think it is a clock time. Who made this rule? What's this? Default. Ah, that's okay, yeah. We're already getting into some of the trickery here. The thing is that there's a default rule. If you say it's 25 a.m. a clock time, it says no. If you say 25 XYZ, it also says no. But this is a low priority rule, default rule. And there's this kind of rule with yes. It fires more easily than the other rule, and it fires when the 9 is between 1 and 12. If you say a proper clock time, this rule fires, and if you say something that is not really a clock time, then the other rule fires. It says no. But already you saw how I got confused reading this. It's generally better to have this kind of program with explicit function calls and objects. You can always improve the objects behind this. You can make the match attractor match more smartly. But then you have a new version of the program, and you can always keep the previous version. This is harder to make, maybe. So we want to get towards this side where we just have examples, and the examples generalize themselves into rules. I think entirely without rules or this kind of attractor thing, you wouldn't be able to make a chatbot. The third way is to use deep learning and just put 2 gigabytes of text inside the bot, and then it learns everything. Just these bots don't work. It's not the right approach. Chatbots need to be made with clever rules and a little bit of learning, a little bit of feedback. So good rules can be promoted, bad rules not so much, and they can be made finer. Every rule can be improved. That's what the learning is for, but just learning as for a bot. I've seen talks by people, actual professionals, who make chatbots with just deep learning, and the bot just regresses. Sometimes it just says bloop or blah. They showed me this in a presentation. They said it's so hard to test a chatbot. It's a little hard, but if you have a solid foundation, it's a lot easier. Thanks, everybody.